So hello friends, mm, welcome to my YouTube channel. Okay, good morning. So uh, let's begin with our today's topic. Okay, so today's topic is Kubernetes volumes. Okay, Kubernetes volumes. Okay, so Kubernetes volumes. Why do we need to have the Kubernetes volumes concept? Right. So because of the storage. Okay, so let's say if you have a database application. Okay, so you will be required some storage to store the data of the user data, let's say, right? So for that purpose you need to have the volumes, right? Because in which you will be going to store your data of the database, है ना, database pods. Okay, so for that Kubernetes volumes is very much required. Okay, so as we have seen already in the Docker volumes, right? So the same concept is with the Kubernetes. Okay, so if volumes are the let's say optional for the stateless application, right? And but volumes are mandatory for stateless application. Okay, so what this statement means? Okay, so volumes are optional for stateless. Stateless means there is only one code. Means from let's say we have uh, generated one pod from the Nginx application. Okay, so you can delete that pod and then you can let's say it will create the same pod again. Okay, so your there is no data in that. Okay, that is means there is any stateless is there. Okay, so no data is involved. Okay, so for that volumes are optional for those stateless application, right? So that it is a nginx application, that is a let's say it is a stateless application. Okay, but volumes are mandatory for the stateful. Okay, stateful applications mean the database which handles the database, right? It holds the state, right? So pod, if you have a MySQL pod, okay, database pod, so you need to retain that state, right? If you delete that, only that particular data will be required, right? Because it will lead to inconsistency there, right? If you do not use volumes for the stateful application, then it will lead to have the inconsistency, right? So there is a concept in the Kubernetes, like let's say this is a Kubernetes volume. Okay, so this is Kubernetes volume. Okay, and then there is a one more concept is in this is called, okay, let's change the color. This is called PVC. PVC is nothing but persistent volume claim. Okay, and one more is there, that is PV. Okay, PV is persistent volume. Okay, so the volumes in the Kubernetes are by default they are not persistent. Okay, so if you define volume entry in the deployment.ml, okay, volume will take from that PVC and PVC will take from the PV. Okay, so if you define the Kubernetes YAML deployment.yaml file, okay, so that will be taking the volume entry for from this PVC. Okay, let's say use pencil here. So Kubernetes volume will take the volume from the PVC, persistent volume claim. Okay, so PVC will check how much volume is required, then he will contact the PV, persistent volume, where the actual volume is there. Okay, so PV is persistent volume. Okay, persistent volume. And by default, our Kubernetes volumes are not persistent. Okay, so we need to make them persistent in order to use your database application, right? Because if we do not so, there will be having inconsistency issue. And PV is persistent volume, and this is persistent volume claim. Okay, it will claim from the PV. Okay, it will claim from the PV. Okay, and this it will create the required storage. Okay, required storage. How much storage we need? Okay, so if you let's say if you want to create 5 GB create on node. Okay, so there are two concepts. Okay, now if you there are three concepts in volumes. Okay, there are three types. Okay, so one is static host path, one is static cloud path, and one is dynamic cloud provision. Okay, so we will see this static host path and the dynamic volume provision, because these and these are almost same, but the difference is it is dynamic and it is static path. Okay, so static host path. Okay, so static host path means host is written there, right? Host is written there. So that means it will take the node's volume. Okay, we have already seen that we have worker node, right? So from that node's volume it will take the necessary storage. So if you are having the volume of the nodes, let's say 10 GB, and you are claiming from the let's say 5 GB. Okay, so it will suffice your requirement. Okay, 5 GB create on node. Okay, so in that case volume will be created where the where it will create the volume where the pod is deployed on that node. Okay, so let's say pod is deployed on the node 1. Okay, so on that on that node it will create the 5 GB of volume. Okay, and it will use the, let's say if you have node 1 have the 10 GB of the total volume capacity. Okay, so it will take from the 5 GB. Okay, so it will suffice uh, till your volume till your node 1 hardware capacity suffices. Okay, so this is the means important point. Okay, so PV will create the required storage. Okay, and so we cannot attach PV directly over here. Okay, to the Kubernetes volume in the deployment.yaml. Okay, so PV will be created on the node. Okay, where your pod is deployed. Okay, so host path, the path you have to give on the node, not on the EBS volume. Okay, so this is the in in the static host path, it will be created on your uh, node volume. But in this dynamic volume, it is volume is written here. Okay, so it will create a separate volume apart from the node. Okay, apart from the node where your pod is deployed. So there will be two entities, one node and one volume. Okay, so we will see in detail the dynamic volume provision. Okay, first we will see the let's say concept of the this one. Okay, so if we see the static host path. Okay, so see this is the PV, right? Let's say this is our deployment.yaml. Okay, and here you can see this is the just deployment only, but here there is a more in that is volume mounts, right? Okay, so we are creating we are considering this is a database application. Okay, that's why we are deploying the volume mounts over here. Okay, so it will take the mount path of the where lib mysql. Okay, sorry. So this is the, let's say this is our deployment.yaml. Okay, so copy from here list. I will so this is our deployment.yaml. Okay, let's say here. Okay, and then take your PVC, right? PVC. Okay, so take PVC. So PVC is what? PVC. Okay, I will explain here. Okay, okay, okay. So this is PVC, and this will be, sorry, PV. Okay, so PV, and this is the our PV. Let's say. Okay, so this is my deployment.ml. This is okay. Let's. This is okay. This is my. This is PVC. Okay, and this is PV. Okay, so how will these three entities should be communicate, right? There should be some similarities in order to have the communication between these three modules. Okay, so how it will communicate? So if you see this claim name, okay, claim name, it is claiming persistent volume claim. It is claiming from the PVC, right? And here it is the claim name MySQL PV claim, right? So this name will match with this here in the metadata of the PVC. Okay, so let's say this claim name, okay, will match the metadata name in the PVC here. Okay, so okay, okay, so this will call like this. Okay, so this is the communication between the deployment.yaml and the PVC file. Okay, so my deployment.yaml saying I am claiming I want, let's say I want some volume from the PVC. Okay, so PVC will be communicating with this the PV MySQL PV claim. Okay, so this is one similarity. How will it will call? Okay, so it will uh, claim some volume from the PVC, but then PV need to communicate with PV in order to take the actual storage from the PV because PVC is just the claiming. It will claim from the PV, but actual storage is here in the PV, right? So there should be some communication between these two files. So PV and PVC is decided by the matching capacity and the access mode. Okay, so this is the matching capacity 5GI, right? 5GB, and here is the storage 5GI. Okay, so this is the matching capacity and the access mode. Access mode is read write once. Okay, access mode is read write once. Okay, so first we'll access mode. Okay, and storage. Okay, and here is also capacity. Okay, so the communication will be like this. Okay, so this will be communication from the PV and PVC. PV and PVC is decided by matching capacity and access mode. Since since I have 5GB and read write once in both PV and PVC, the binding is successful. Okay, so it will be successful if we this condition mean this terminology are matched with this. Okay, so this is very important in order to have the actual PV actual volume. Okay, so this will be taken from the your nodes volume. Okay, node hardware, right? So this is the this is about the static host path. Okay, so let's start about the practical for this. Okay, okay, so first check me. Yes, my cluster is deployed. kubectl get pods. Okay, no pods is there. kubectl get nodes. Okay, my nodes are ready. So I will first install the git sudo yum install git hyphen y in order to import the Kubernetes repository, right? So here is my repository, Kubernetes main. Take this HTTPS repository. So git is installed. So git clone. Okay. So lslrth it is clone. Go to cd. Okay. Where is volume? Date 10. cd date 10. Okay. ls-lrth. Now we need to see the static host path, right? Host path means it will create the volume on your host, on your node, right? So there are already three files, right? So we will we have already seen this file, right? Let's say pvc.ml. We have already seen the deployment, right? So this is the persistent volume claim file, right? MySQL PV claim. We have access mode, and this is the storage. Required storage is 5G, right? So this is claiming, right? This is kubectl apply hyphen f pv.ml. Okay. Okay. So PV is created. So how to interpret kubectl get PV. Okay. So you can see that access mode is read write once. Okay. So read write once. Okay. So I will tell you about this. Control home. What are the storage modes now? Read, write. Okay. RWO. Okay. There is a separate those are the access modes. Okay, access mode. Okay, read write once, read write many. Okay, so by applying those means you are defining how to access your volume. Okay, how will it write? Okay, uh, yeah, see here, read write once. If you need to write to the volume, but either you don't have the requirement that multiple pods should be able to write to it. Okay, so read write once means only one single pod should be able to write to the write to the volume, not multiple pods. Okay, so and what is the difference between read write many? In this case, there will be multiple pods needing to write to the volume. Okay, so this is the difference between read write many and the read write once. Okay, so our volume is created now. Let's say, okay, so reclaim policy retain status is available. Okay, storage class, leave it, and our access mode is read write once. Okay, and storage capacity is 5, and it is available. Okay, so let's create now the PVC. Okay, kubectl apply hyphen f PVC. Okay, so PVC is also created. How to check? Kubectl get PVC. Okay, so status is bound, it is created of the capacity 5Gi, read access mode is read write many, and volume attribute is unset. Okay, so it has created our PVC. Okay, so now deploy the YAML file, our deployment file, kubectl apply hyphen f deployment.ml. Okay, so this is our MySQL pod. Okay, how to check kubectl get pods. Okay, so it is creating and it container creating. Okay, It is taking some time. Okay. Okay. So it is running now. Okay. So this is my SQL pod. It is getting created. Okay. Because if you see this file, no. Okay. That is of the deployment. That is a MySQL file. Okay. MySQL deployment. So pod is of our MySQL database. So how to log into the container created? How to log into the pod? kubectl exec, right? Hyphen it interact terminal and give your pod name. Space hyphen space bin bash. Okay, enter. So it will ask for the we have logged into the MySQL pod. Okay, so we need to have the MySQL client over there, right? In order to go into the MySQL database. So give the command like MySQL hyphen u root. This is the password. This is the username and hyphen p. Okay, so what is the password? Let's me see. Volumes. Okay, deployment.ml. There is password. Okay, value is password. Okay, so just give this value over here. Password. Okay, so we have logged into the MySQL now database. Okay, so just create here any, let's say, database and table. Okay, so let's say create database test. Okay, okay, so I created the database. How to check that? Show databases, right? Show databases. See, the test database is created, and the rest are these are the default ones. Okay, it is created by the system default. So our database is created. Okay, so let's create one table also in that. Okay, say create table test. This is the database and users, which is my table name. Okay, users. Give the let's take create table command, right? Create table test dot users. Okay, do we have? Okay, so this is take this one. Create table person. We will change the. Okay, where was she? Okay, okay. So change the here test dot person. Oh, stop. Oh, so do one thing. Uh, in the notepad plus plus open. Okay, here define your table. Okay, test dot persons. Okay, so we have logged in from this. So try with the same. MySQL give MySQL root hyphen p with the password. We have logged in. We have already created the database, right? Just check whether it has been there or not. Show databases. Yes, it is there. Now execute this table command. This is the SQL command, right? Okay, so our table is executed. Okay, so how to view that table? First, we need to use database test, right? Use databases, I think, or simply give the use test. Okay, don't need to give the word database. Use test. Okay, so we are using this database and check the command that is show tables, right? So this, see, this person table is created, right? So where these tables database will be stored? Okay, so they will be stored on the node volume, right? Where your pod is deployed. So we can check that kubectl get pods on which node is it deployed, right? Hyphen O wide. Oh, sorry. So come out of this, Control Z, exit, exit. Okay, so we have come out of. So let's execute now. How on which node is our pod is deployed? Kubectl get nodes hyphen O wide. So this is the our okay, sorry. First we need to check the on which node our pod is created, right? Okay, so it has created on the this node 14196. Okay, 14196. This is the internal IP. Okay, and the external IP is this one. Okay, so go to our this is in our which region we have given in the Mumbai region. Okay, so go to Mumbai region AP South one where our worker nodes are deployed. Okay, on that we will be checking whether this volume is created. Okay, so we need to connect this node. Okay, so how will be connecting to this node? We need to allow, sorry, we need to first check the IP 1496, right? 14196. Okay, so this is the 14196. Okay, so copy this and we need to log into this node, right? So first we need to enable the first we need to enable the uh, allow incoming traffic, right? Let's say we are allowing to the 00 all traffic. Okay, save rules. Okay, we have allowed and now go to this node 14196. Okay, connect to this. I don't know whether we'll be connecting directly or not. Let's see. Yeah, we are connected. So where we have given our path, that is where MySQL let it be. Wherever we have created the in the static host path our PV, where we have created volume slash MNT data. So go to this path here, no, CD MNT data, right? Give ls upon lrth and check. Here, here is the database, right? June 6, 57. Okay. So CD test, go to the database, and here you can check persons.ibd, right? So that table which we have created, we can see in the nodes volume, that is person.ebt. So can you So once node is deleted, this DB is also deleted, right? Okay, so you can't see this file, right? Apply hyphen f dot. Okay, so it will delete everything from this. Okay, so we have deleted the static host path. Now we will move to the dynamic volume path. Okay, so this is our dynamic volume provision. Okay, so in the dynamic volume provision, we have only two files, that is deploy.ml and storage.class. Okay, storage class. Okay, so first we will understand the concept. Okay, so we'll understand the concept first. Okay, so here we need to have the, okay, so let's say control and here is where is space. Okay, so I will use this space. So let's say I am creating one, I am using in the dynamic volume path, we are using the external EBS volume. Okay, external EBS volume. So this is my EBS, and let's say this is my MySQL pod. Okay, this is my MySQL pod. So MySQL pod is deployed on the node. So it will take the volume from the EBS. Okay, it will take the volume from the EBS, and EBS will provide the required storage to the MySQL pod. Okay, so these are two separate things, right? Your volume is not deployed on the node. It is deployed on the another node, that another volume, right? It is, so both are not the separate, both are the separate entities over here, right? So to communication between them, you need some similarity between them. How will they communicate? Okay, so in the dynamic volume path, okay, whenever you deployment.yaml is created, that time automatically create the, when you will create the deployment.yaml file, right? When you will run the deployment.yaml, that time automatically create one EBS volume, okay, inside your instance, okay, where your pod is deployed, but it will take the volume from the external EBS one, but it will create in the your instance where your pod is deployed. Okay, so to enable this, okay, we need to install the CSI driver, okay, in EKS cluster. So why we need to install the CSI driver? Because both are the separate entities, right? Both are the separate entities, means EBS is separate entity, and MySQL pod which is deployed on the node, it is a separate entity. Okay, so there should be some compatibility between those two things. That's why we need to install the CSI driver, okay, in EKS cluster. So there are ready-made step I have already included. Okay, so CSI, where it is. Okay, okay, so see here, install CSI driver in EKS cluster by following commands. Okay, so in order to install the CSI driver, first we need to have the Helm. Okay, yesterday we have seen the Helm, so I have already deployed the Helm. Okay, go to check Helm version. Just check whether it is there or not. Yes, it is there, right? So I have already installed the Helm. Okay, so first go to the uh, install the CSI driver. Okay, so okay, first we'll check the, let's say, mm, concept. Okay, concept of the uh, dynamic volume path. Okay, so if you see this path, okay, so this is my storage class. Okay, so what storage class is? Okay, so My metadata I given in the EBS storage provisioner. Okay, so this provisioner is calling the CSI driver. Okay, we are giving the entry of the CSI driver over here in the provisioning mode. Okay, so volume binding mode. Okay, so volume binding mode is, so whenever you run deployment.ml, that time storage class. Okay, this storage class will create one EBS volume. Okay, on the node end. Okay, so volume bind is here is wait for consumer. Okay, so just copy this. I will explain here. New file. Okay, new, or we don't have any. Let's say print. Okay, so here is my storage class. Okay, this is my storage class. Okay, and let's take the deployment.ml dynamic volume. It is creating the volume dynamic whenever you will be running the deployment.ml. Okay, so this is the deployment, this is the stateful set. Avoid this, I will explain in later. Okay, so this is the volume claim template. Okay, it will call the storage class from here. Okay, so take the snapshot from here. Okay, so this is your deploy.ml. Okay, this is your storage class. Okay, so how will you ensure the communication between these? Okay, so this is the name over here. Okay, see this storage class name, right? This storage class name, EBS storage, right? So this deployment.yaml is calling the storage class by this name, EBS storage. Okay, so it will match the name over in the metadata of the storage class, right? So this way it will be communicating. So the deployment.family, when you create, it will call the storage class by this keyword, EBS storage, and it will match for the required keyword in the metadata section, whether this storage class belong to this deployment.yaml or not. Okay, so this is how they will be communicating storage class and the deployment.yaml. Okay, and access mode we have already seen that. Okay, read write once. So this is the MongoDB uh, application. Earlier we have seen the MySQL one. Okay, so uh, one more thing is there, that is volume bind, right? Volume bind, this one. Volume bind is what? Wait for first consumer. So what this meaning is? So whenever you create the storage class, no, it will not create any ABS volume immediately. It will depend on deployment.ml. When you will be, whenever deployment is created, after that only it will create the EBS volume. That is why there is a wait for first consumer, wait for deployment.yaml to run. After that only your volume will be created, right? So there is another is there, another volume type is there, that is immediate. So immediate in what? Immediate will deploy your volume at that moment only. Whether you run your deployment.yaml or not, it will create. Okay, so unnecessary, it is not, immediate is not recommended, right? You are not supposed to create any EBS volume before creating pod, right? As you have to pay for that. Okay, so it will be waste of the resources and waste of the money also. So it is not recommended the immediate one. So generally we will use the wait for first consumer only. Okay, so let's move with the practical. Okay, where is our, okay, so the, okay, so I have already deleted the earlier one, right? The static host path. Now go to ls hyphen lrts go to first. Okay, first we will need to install that static host path. Sorry. Okay, first we will go to this cd dynamic host volume provision ls hyphen lrth. Okay, so those two files are there, right? Storage class and deployment.ml, what we have seen in the paint now. Okay, this one. Okay, so uh, first we'll create the that storage this EBS CSI driver. Okay, so install this has been added to your repositories. Okay, I have added an Helm repo update. Okay, update has been done. Install EBS driver to Kubernetes. Okay, it will install this. Okay, is it installing now? Wait for a moment. Okay, I think it is installed now. Okay, so first create the your storage class. Okay, kubectl apply hyphen app c.ml. Okay, okay, so storage class is created. How to check? Kubectl get sc. Okay, so you can see that it is created EBS storage, and this is our CSI driver. Okay, it is taking the entry from the CSI driver, and see the volume binding mode is wait for customer, right? And GP2 is the your GP2 is the general purpose volume. Okay, so these are the two entries over here, and then you will be running deployment.ml, right? Apply hyphen f. Okay, so this is the MongoDB pod will be created. Okay, okay, kubectl get pods. Okay, so earlier one was okay, that was of the MySQL one. Okay, so ignore that. Okay, I will delete that kubectl delete. Not sure why it is. Okay, it is deleted. MySQL one. Now check. Okay, so it is creating new one. Okay. It is going into pending state. Okay, so why it is going into pending state? Because that will be created on the our node group. Okay, node group. So we need to have the we need to have the EC2 full access over there. Okay, node group. So mhm, go to the node group. Okay, uh, where will be those EKS, right? EKS node group resources. Okay, compute. So here is the node group. Okay, and here you need to enable the EC2 full access. Okay, where is this launch template where we need to give auto scaling group? Okay, view in IAM. Okay, so here we are not having any EC2 full access because on the node group we are accessing the volume of the volume which is created on the EC2 on this server. No, on this server we have created the volume, that test server. Okay, so we need to give the EC2 full access for this cluster in the node group, right? So give here the EC2 full access. EC2 full. Okay, how to add permissions, test policies, EC2, EC2 full access. Okay, so see this and add permissions. Okay, so we have given this policy, given this permission to EC2 full access to the node group. Okay, now let's create once again, that is create the delete and again. Okay, so that it will be effect. Where is that? Okay, so kubectl delete apply hyphen f. Okay, kubectl delete hyphen f dot. So it will delete all the thing. Okay, so all the thing is deleted. Now check kubectl get pods. Okay, that is already there. Okay, so first remove that one. CD static, right? Static host path. Kubectl delete hyphen f dot. Okay, so it will delete all the things. Okay, it has deleted. Now go to CD dynamic. Okay, kubectl get pods. So no resources, right? So no pod is there. So now create the fresh one. That is kubectl apply hyphen f sc. Okay, the source storage is created. Now kubectl get sc. Okay, so wait for consumer, right? And now check your run your the deployment.ml. Okay, so it has created the MongoDB. Okay, and just check now your pod status kubectl get pods. See, it is creating now, right? So that was the reason, right? It was the pods was not deleted, and we have not given the EC2 full access in the node group of the cluster because it is the external volume we are which is we created in the EC2. Okay, so this first one is the MongoDB, that is master, and second one is the replica of that pod. Okay, so this is the it is still creating. So if you notice, okay, it is creating only. It will creating. See, right? It will create. So if you have notice, okay, so if you have noticed, we don't have any PVC here, right? But if you interrogate, you will see PVC, right? So PVC is mentioned in your deployment.ml, right? It is mentioned in the deployment.ml that we are claiming volume claim template. This is nothing but PVC only. Just that it is in the deployment.yaml file. There is not separate entity over here. Okay, you cannot make it a separate entity in the pvc.yaml, but here I have defined it in the volume claim template. Sorry, in the deployment.yaml. Okay, so you can see that these are the three pods. Okay, so all the three pods are running. So this is how we create the dynamic volume provisioning. Okay, whenever you run the deployment.yaml, that time your volume is created. Okay, we have checked and verified with the help of practical. Okay, so this is about the Kubernetes volume. Okay, I hope you like this session. Thank you. Thank you for your support and patience. We'll meet again soon. Till that time, goodbye.